So let's continue with 5.6, definite integral substitution and the area between curves. So here we have an integral from -1 to 1 of 3x squared times the square root of x cubed plus 1, and we're integrating with respect to x. Okay, so with this problem, what we're going to do is we could do this a couple ways. I want to show you guys two ways. First way I'll do is with just regular substitution. Right? I mean, they're both with substitution, but it just depends on how you evaluate with the bounds. Okay, so we're going to say that our u, we see that our u is going to be the x cubed plus 1. When we take the derivative, du would equal 3x squared dx. And so when we see that we already have that du in there, right? 3x squared dx is there. So we're going to integrate this. When we integrate, we have u to the 1/2, and we have du. Okay. So when I integrate it, I'm not going to put my bounds in there in the integral. So I'm leaving the top and the bottom here blank. So I'll integrate, and then what I'm going to show you guys is why I'm doing that. Okay, because according to this, with my u, those are not my same values in terms of u. So for now, I'm going to leave those blank. I'm going to do my integration, and then I'm going to plug back in with my x cubed plus 1, and then I'll evaluate the bounds. Okay, so there's a technical rule there. We don't want to confuse the bounds with the bounds for x versus the bounds for u. Okay, so we integrate. This will become u to the 3/2 divided by 3/2 or multiply by 2/3. Okay, so now what I'll do here is I'll plug back in my substitution. My u is equal to x cubed plus 1. So I have 2/3 of x cubed plus 1 to the 3/2. And this is where I'll evaluate from 1 to -1. Okay, so let's go through that problem. We plug in 1, so we have 2/3 of 1 cubed plus 1 to the 3/2, and then we would do is minus 2/3 of -1 cubed plus 1 to the 3/2. Okay, so when we go to finish this off, we have the 1 cubed is 1, plus 1 is 2. Minus 2/3. -1 cubed is -1. -1 plus 1 is 0. So we have 0 to the 3/2 times 2/3. So this is 0. So now we're going to evaluate the left side. We have, we're going to do 2 to the 3/2. So the denominator tells us that it's a square root. It's a square root of 2 cubed. So if we do that, that's a square root of 8. And if we simplify the square root of 8, simplest radical form, that would be 2 radical 2. So I have 2/3 of 2 radical 2, which tells us that that would be 4/3 times radical 2. Right, the 2 and the 2 can multiply, so we could even have like this. We could have 4 radical 2 over 3. Okay. All right, any questions on that? We could discuss it. Now let me show you the version we could do with the u bounds. Okay, so let's do the same problem with the u bounds. So we're going to evaluate 1 to negative 1, negative 1 to 1, 3x squared. And the square root of x cubed plus 1 dx. Okay, so now we know the u is going to be x cubed plus 1. And we know du is going to be 3x squared dx. Okay, so as we do this with u, we could integrate with u as well. We don't have to switch back to the x cubed plus 1 at the end. Okay, so when we do it with u, we have to figure out what these bounds are going to be in terms of u. Okay, so these are the bounds with x. So you're going to pretend like your x is negative 1. You want to figure out what the u is. Okay, so you're going to say when x is negative 1, let's figure out what u is. So use our substitution model here. U equals x cubed plus 1. When x equals negative 1, let's plug it in. Negative 1 cubed is negative 1 plus 1, which is 0. So in our new integration, we'll have a 0 there. Okay, and now let's do it for the upper bound. When x equals 1, u equals 1 cubed plus 1. 1 cubed is 1 plus 1 is 2. So that means our upper limit of integration would be 2. Okay, so now let's go through and again do this in terms of u. So we have, this would be u to the 1/2 du. And so now we could integrate this, u to the 1/2. If we add a power, that becomes u to the 3/2 divided by 3/2 or multiply by 2/3. And so now we could just evaluate it with 2 and with 0. Okay, so we'll have 2/3 of 2 to the 3/2 minus 2/3 of 0 to the 3/2. Well, 0 to the 3/2, that's just, right, that part's just 0. And then this part, 2 to the 3/2, that's what we just did earlier. Right, that becomes the square root of 8, which becomes 2 radical 2, which gives us 4 radical 2 over 3. Okay, so you could do this either way. You could do it with the original bounds, or you could do it with the new bounds in terms of u. Just remember, if you do it in terms of u, you have to adjust the bounds to what the new bounds would be in terms of the u bounds. Okay? Any questions on that, you could ask me during class. Let's take a look at our next theorem. It says theorem 8, let f be continuous on the symmetric interval. Okay, negative a to a. So these are just two basic properties. If you have an even function, like we have here on the left, right? This is symmetric about the y-axis. Then you know that you could easily do the same integral. Instead of going from negative a to a, you could instead do from a to 0, and then just double it. And that's what this is telling us. Right? You do this integral, and you know the other half is the same, so you just do from the 1/2 and then double it to get the full area. If you have an odd function, okay, kind of like what we have in this second piece, you know that an odd function, if you have a positive area and then this would be like a negative area, these are going to cancel themselves out. So this top piece here in peach with the bottom piece here in peach, they will cancel each other out. And the same thing happens with these blue pieces. They will also cancel each other out. Okay, so if you have that, if you have a function that's odd, and you're going from a to negative a, or negative a to a, they will cancel each other out. You'll get a net area of 0. Okay? Alright, a net integral of 0. You could still do the area of this problem. You just have to remember to take the absolute value of these negative pieces to get the net area. Okay. So when you're doing area problems, just remember for the negative pieces, you'll have to do absolute value. Okay, let's take a look at our next slide. Area between curves. Okay, so if you have two functions that are continuous and one function is greater than the other one, like in this case, the function of f of x is greater than or equal to the function g of x. I like to call these, like f of x would be the top function, g of x would be the bottom function. Okay, then we would do f of x minus g of x, so top minus bottom, and then integrate on the bounds of integration. Okay. Okay, so let's do an example. Find the area of the region enclosed by the parabola and the line y equals negative x. Okay, so the parabola y equals 2 minus x squared. That's the same parabola as if we do negative x squared plus 2. Right, if we just rearrange it. So we know that the negative x squared, that's going to be an upside down parabola, opening downwards. 2 would be the y-intercept. Okay, so we go something like this. The line y equals negative x, so the line y equals negative x will go something like this. Okay, so that means what we need to do then, if it's the area enclosed by the parabola, we're trying to figure out this area. Right, this piece. So for that to happen, we need to figure out what are these intersection points, right? In order to figure out our B and our A. So we don't know what these are. Okay, so if we don't know what those are, we can set the two functions equal to each other, and then we can figure it out. So 2 minus x squared equal it to negative x. And let's figure this out. Okay, so I'm going to move everything to one side because it looks like it's going to be a quadratic. I'll move the x squared to the right. I'll move the 2 to the right. So minus 2 and plus x squared. Minus 2 and plus x squared. I'll put it in standard form. So this will look like x squared minus x minus 2. Set it equal to 0. Luckily, we could factor this. We could factor it, set it equal to 0. If we factor it, what multiplies to negative 2 and adds up to negative 1. multiplying to negative 2 would be negative 2 and a positive 1. Okay, set these equal to 0. X minus 2 equals 0. X plus 1 equals 0. That means we have x equal to 2 and x equal to negative 1. Okay, so that means this one must be 2 and this one must be negative 1. Okay, so there's our bounds of integration. Okay, so we have integral from negative 1 to 2. Now remember what I said, it's going to be top minus the bottom. Okay, so your top curve is your parabola, 2 minus x squared. Bottom curve will be the negative x. Okay, so we have 2 minus x squared minus negative x. And we're going to integrate this with respect to x. Okay, simplify that minus negative, so we have integral 2 minus x squared plus x. And now we're going to integrate it. Okay, so when we integrate this, we have 2x minus 1/3 x cubed plus 1/2 x squared. And we will plug in 2 and negative 1. So when we plug in 2, we have 2 times 2 minus 1/3 times 2 cubed plus 1/2 times 2 squared minus, plug in negative 1, so 2 times negative 1 minus 1/3 times negative 1 cubed plus 1/2 times negative 1 squared. Okay, I always like to put the part that's being subtracted, I like to put that in parentheses. Okay, just a word of advice I would suggest to you guys as well. Okay, so let's simplify this. We have 2 times 2 is 4. 2 cubed is 8 times 1/3, that's 8/3. 2 squared is 4. 1/2 times 4, half of 4 is 2. Okay, on the right side we have 2 times negative 1 is negative 2. Here we have negative 1 cubed, which is negative 1, times negative 1/3. So negative times negative is positive, so plus 1/3. Negative 1 squared is 1, times 1/2 is 1/2. Okay, next we have the 4 and the 2. We can combine those, we get 6 minus 8/3. Here we have a minus of a negative, so that's going to be a plus 2. We have a minus 1/3, and we have a minus 1/2. Okay, the minus 8/3 and the minus 1/3, we combine those. At the same time, we could combine the 6 and the 2. So let's do that first. 6 and 2 is 8. Then we have the negative 8/3 and the minus 1/3. That's negative 9/3, correct? That's negative 9/3. So that's negative 3. And then we have the minus 1/2. Okay, so we have 8 minus 3, which is 5. 5 minus 1/2 would be 4.5. Or if you want improper, 9/2. Okay. Any questions, just let me know. Okay, let's take a look at our next problem. Find the area of the region in the first quadrant that is bounded above by y equals square root x and below by the x-axis and the line y equals x minus 2. Okay, so to get a sense of this problem, let's graph it. Y equals square root of x, that should be our half parabola. Right, that should be a half parabola. I'll be opening like this. And then the line y equals x minus 2. X minus 2, so y-intercept of negative 2, slope of 1, so should be going like this. Okay, so area of the region in the first quadrant that is bounded above by, okay, square root of x, below by the x-axis and the line. Okay, so we're talking about this region. Okay. So this is nice and all, but the only problem here is when we do the top curve minus the bottom curve, when we get to this region here, we're kind of stuck because we don't have that bottom curve because we're bounded in the first quadrant. Okay, so we're going to have to split this up right there. We have to split it up into two integrals. Okay, we're going to split it up from here to here, and then we're going to have to do another separate one, just a basic one from here to 0. Okay. Okay, so let's figure out what our bounds are going to be. So let's figure out first where square root of x meets up with x minus 2. Okay. So if we look at this square root of x, let's do some points. Let's do square root of x. Let's do some basic ones that we could take the square root of. 0, 1, 4. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And then y equals x minus 2. Okay, let's go 0, 1, 2, 3, 4. Okay, so if we do 0, we get negative 2. 1 is 1 minus 2, negative 1. 2 minus 2 is 0. 3 minus 2 is 1. And 4 minus 2 is 2. Okay, so we see that they both meet up at 4, 2. So that means 4 is our x value there. And then looking at the line, where the line hits the x-axis, that's our x-intercept. X-intercept happens when the y is equal to 0. So our x-intercept is right here. So that's 2, 0. So x is 2. Okay, so now, and then this would be 0, of course, at the origin. So we know that what we have. Okay, we have an integral from 2 to 4 of top curve minus bottom curve. So that would be square root of x minus x minus 2. And then we're going to add that to integral from 2 to 0, or 0 to 2, of just basic square root x dx. Okay, so let's figure this out. Okay, so when we go to integrate this, we have x to the 1/2. So that would be x to the 1/2 if we integrate. What I'll do first, I'll throw in this extra step. We're going to distribute that minus sign. So I have x to the 1/2 minus x. Minus of a minus is plus. Okay. And we have x to the 1/2 here. Okay, so let's integrate. We're going to raise the 1/2 by 1. So that's adding 1 to that would be adding 2/2. So that gives us x to the 3/2 over 3/2, or like we did earlier, multiply by 2/3. Minus 1/2 x squared plus 2x. And now for this other one, we have just 2/3 x to the 3/2, and we'll evaluate from 2 to 0. Okay, so for the one on the left, we're going to plug in 4, we're going to plug in 2. We have 2/3 of 4 to the 3/2 minus 1/2 of 4 squared plus 2 times 4. We go down below minus 2/3 of 2 to the 3/2 minus 1/2 of 2 squared plus 2 times 2. Okay, so now when we go to simplify that, now my 4, I'm going to take the square root. My 4 would be 4 cubed, 64. So square root of 64 is 8. So I have 2/3 times 8 minus 4 squared is 16. Half of 16 is 8 plus 2 times 4, 8. See a lot of 8s here. Okay, this next one, we have 2/3. 2 cubed is 8. Square root of that would be 2 square root 2 minus 2 squared is 4. Half of 4 is 2 plus 2 times 2 is 4. Okay. Alright, so now notice what we have here. I have a minus 8 and a plus 8. They will cancel. So I have 2/3 of 8. 2 times 8, that's 16 thirds. Now over here, I have 2 times 2, that's 4. 4 square root 2 over 3. And then inside the parentheses I have negative 2 plus 4, so that's a negative 2 plus 4 is a plus 2. Okay, so now what we'll do, we also have something up here. I want to also not forget about that. So I'm going to evaluate my second half here. I'm going to plug in my 2. So I have 2/3 of 2 to the 3/2 minus 2/3 of 0 to the 3/2. Okay, so the 0 part, that's gone. 0 times anything is 0. 0 to the 3 halves is 0. So here I have 2 to the 3 halves. That's like what we did here in the first part, right? That gives us 2 cubed is 8, square root of 8 is 2 square root of 2. Okay, so that means I have here a plus 2 times 2 is 4. So I have a plus 4 square root 2 over 3. And now notice what's going on. I have a minus here in front in the beginning. So the minus 4 square root 2 over 3 and the plus 4 square root 2 over 3, they will cancel out. So these two are gone. So this minus will go into here and become a minus 2. So I have 16 thirds minus 2. So that becomes 16 thirds minus 6 thirds. So my final answer will be 10 thirds. Okay. Alright, so any questions we could discuss in class? Okay, so now let's take a look at another way to do the problem. But first, let's discuss a little bit about integration with respect to y. So if we have integration with respect to y, we're going to be looking at the problem basically tilted to its side. Okay, so when you look at with respect to y, y is kind of acting like our x-axis before. Okay, so this is like, pretend like this y is the x. Okay, so now you're still going to do top function minus bottom function. So in this case, the top is going to be like the outer function, like the one in the yellow here. And then the bottom function is going to be like the one in the blue. Okay, same thing for here. Top would be the one in the yellow, bottom would be the one in the blue. Okay, but remember, everything has to be in terms of y. So if it's y in terms of x, we have to switch it around and say x equals, and put it in terms of y. Our bounds of integration will also change. There will be bounds of integration based on the y's. Okay, so we'll have those. Let's take a look at the same problem. Okay, but now do it in terms of y. Okay, so we knew what the graph looked like. We already did the graph, so we know that we have square root of x, and we have the line coming up like this. And we know that this is the point here was what, 4, 2. Okay, so this is 2 then. And if we go in 2, and we're looking for the second point, this would be 0. Okay, so when we do the integration, we go from 2 to 0. It would be if you're looking at it from the side, the top function will act like the line. Okay, the line will be the top function minus the bottom. The bottom will be the square root of x. Okay. But remember, what we need to do is get the functions in terms of x equals in terms of y. Okay. So let's do that. So for this first function with the y equals square root of x, we could square both sides. So we have x equals y squared. Okay, so that's our one function. And then for our other one, y equals x minus 2. Again, solve it for x, so add 2. So we have x equals y plus 2. Okay, so let's do the integration from 0 to 2. Remember, top function minus bottom function. In this case, it would be our line, y plus 2 minus y squared. And this will be all with respect to y. Okay, so we have y plus 2 minus y squared. Okay, let's integrate it. So we have 1/2 y squared plus 2y minus 1/3 y cubed. And we're going to go from 0 to 2. Okay, plug in 2. Plug in 0. So we have 1/2 of 2 squared plus 2 times 2 minus 1/3 of 2 cubed. Minus 1/2 of 0 squared plus 2 times 0 minus 1/3 of 0 cubed. Now this whole second piece is going to be 0, right? 0 squared is 0, 0 times anything is 0. So this is 0. So we can focus on the left side then. So we have 2 squared is 4. 1/2 of 4 is 2. 2 plus 2 times 2 is 4. And then here 2 cubed is 8. We have 1/3 of 8, so that's 8/3. So we have 2 plus 4 is 6 minus 8/3. Let's get this in terms of thirds. So this would be 18/3 is the same as 6. So 18/3 minus 8/3. And that would give us 10/3. Okay, so same way to do the problem. Same result, but different way to do the problem. We integrate with respect to y versus with respect to x. Okay, same answer, 10/3. If we look back at our previous version, 10/3. Okay. Okay, so that's it really for our review of 5.6. If you have any questions, just let me know, email, or bring it up during our lecture. Okay, during our class meeting. Okay, have a good day, have a good night. We'll see you soon.